Still ticking. Okay. Welcome back for day 2 of PackagingCon. We are kicking this off with a panel on package manager convergence, which is really close to one of the themes of the conference. We wanted to bring everyone together to see what could be shared or maybe what can't be shared between different package management communities. And so I'm going to share my screen here. Let's see, share screen. And go here. All right. So the title of this panel is Package Manager Convergence, What Stands in the Way? And before I get into the charge questions for this, I just wanted to say, sorry about the mantle. We have a bunch of men on this panel, and we tried to have a more diverse one. But I guess I'll take the blame for that because I started organizing this panel way too late. And so for next year, I think, and in general, we probably need to do more to increase diversity in the packaging community. It is a pretty predominantly white male community. And, I think any ideas on how we could be more inclusive there would be much appreciated. So sorry about that in advance. So the charge questions for this panel are as follows. Do you think there's too many package managers? Why or why not? What parts of packaging could eventually be automated or replaced by infrastructure? What parts of package managers do you think could be shared as common components? And what would it take to make that happen? If not through common components, then what ways could the many different packaging communities come together in the future? And then what do we need to do to get people outside the packaging community to better understand all these challenges? So we asked the panelists to think about these questions and prepare some slides, and or just to give an initial take on it. And so what we'll do is we'll go through the different panelists and have them give their take on this, and then we will open it up to the audience for questions, and I'll also be moderating the discussion. So with that, I'm going to turn it over to whoever appears first in my view over here. So let's see, I'll stop sharing. I'm going to go with Wolf first. I guess since he's the organizer of the conference, he gets to kick it off. Let's see, Wolf, go for it.
Yes, thanks, Todd. Yeah, indeed, I'm also very excited about this. I have the power to press the button to add my own screen.
All right.
Yeah, so I have a lot of thoughts about this, but I will present my quick thoughts right now. So to the question if there are too many package managers, I think maybe, or at least we should share more of the pieces that make up a package manager. And I will kind of give my take on that in 3 slides. I think what's been missing for a long time was libraries that do package management in a cross-platform fashion. And the cross-platform is important because I think part of the reason why language-specific package managers exist is because they kind of live on this other axis where you need to support multiple platforms like Windows and Mac OS, while we already had like an established ecosystem of Linux package managers. And so they kind of exist in these like parallel universes. And I also think that some package management problems are really, really hard. And I don't really think it's worth it to solve it multiple times. One other thing that I want to get to, so because one of the questions was how can we share more across like our different ecosystems. So one thing I really love is Wikidata and also OpenStreetMaps and Wikipedia, obviously. But I think Wikidata is the most appropriate example here. In Wikidata, you can have all kinds of entities. One kind of entity that you can have is software. And so here we have a C++ library that I actually put in because I used to work on that. And also like all the software version identifiers here on the right. And Wikidata is a collaborative source of knowledge. It's a huge knowledge graph that encodes like the entire universe, like hopefully soon, and gives it like a unique identifier here. And I really think that the software packaging community and Wikidata, for example, we kind of share a lot of traits. We are kind of similar nerds. And so if we have some sort of like knowledge graph or source of wisdom for our central metadata, I think that could simplify like having all these different package managers and encode stuff. So one thing is, for example, names and namespaces, versions, licenses, dependencies, which is probably the hardest part, or maybe build scripts is even harder. And So a project that I'm part of is conda-forge, and it's kind of a prototype of that, I would say, because we do encode recipes as like mostly static YAML and have dependencies in there and encode like metadata like licenses and all that. And another question that was asked is whether we can replace many things with automation. I think conda-forge also shows that, yeah, a lot of automation can replace human labor, basically, in package management, because there are bots that automatically increase version numbers and lint for licenses and all that kind of stuff. Another project that was shown to me in one talk yesterday, actually, which I was really happy to see, is Perl. It's a unique package URL. So maybe some of you haven't seen it, but the idea is to uniquely encode all packages. For example, use like this PyPI namespace here, and then Django, and then some version, and similar for Fedora packages. There's a whole spec that's being developed. I think it would be a great idea to check it out. And I just want to say a bunch of words about common operations of package management. I think if you break it down, you will find that some of the like basic operations could probably be shared by all package managers, or are shared by all package managers, and could maybe end up in some library that everybody can use. And so one thing is like downloading or even uploading and then checksumming files, which in a cross-platform fashion, libcurl and OpenSSL can really do well. Then solving for package dependencies. There are libsolve and pubgrub, which are two pretty good contenders. Extracting and compressing artifacts. I think libarchive does a really good job at that. Then artifact and metadata signing. So the update framework is one initiative to standardize this. And OpenSSL has also been really established for doing this, or checking signatures. And artifact storing in package registries. I think OCI is kind of doing this now in a standardized way. And one thing that I've also been really interested in is to figure out how we can have like a cross-platform shell scripting language, or do that in a more easy way. If you've ever used Command Excel, you know maybe how hard this can be. And there's a kind of prototype with multi-sheller, but maybe we should just standardize around Python. And that are all my slides.
All right, so let's go to Andrew here. What do I do here? How do I put him into? Let's see. Wolf, do you know how I actually add Andrew to or have Andrew share his screen? Or does he just need to share his screen?
I've got my screen already.
Oh, there we
shared,
go. Okay, it worked. Great.
There we go.
Take it away, Andrew.
So when I looked at these questions, I kind of came a little bit of a contrarian direction, and rather than thinking about how convergence can be reached, I was thinking, why do we see divergence happen on a fairly regular basis? I mean, there's already a lot of package managers, and most new languages seem to kind of generate them as they appear. Why does that happen? If we can understand why new ones are created, then maybe that gives us pointers as to how we can look to kind of maybe change that direction, or at least support the kind of shared patterns between them. So why would someone want to build a new package manager rather than reuse an existing one? Lots of different reasons I thought of. Existing package managed systems can be really difficult to try and contribute to sometimes. There are lots of code, lots of legacy, and making changes to those systems can be difficult, or maybe not even really open to contribution in the case of some package managers. And you can, if you wish to try and enact a change or experiment with something, it can be very difficult to actually be able to kind of really make a difference in a existing system, which might make you want to kind of try starting a new unique project. Also, if your language has some interesting unique features, it can be that an existing package manager doesn't really take much use of that. I mean, we see that with npm, where JavaScript has first-class functions. A package can actually be included in multiple versions within the same runtime environment without those different versions clashing, whereas a lot of languages don't really allow the same module to be loaded multiple times. Questionable if you should really do that, and there is some very weird edge cases that you can run into, but those kinds of features that exist in a language often then kind of encourage divergence in a package manager because they want to make use of those features or at least try them out. Also, like getting permission to do that for, say, if I wanted to start adding packages to apt, there's a lot more hoops that I need to jump through to become kind of get into the position where I have the ability to do that. Then that kind of comes down to this namespace idea. Each new registry kind of comes up with its own blank, fresh namespace, which is really attractive to begin with, to some of the properties that comes along with being able to have it kind of empty and all of the short names suddenly become available again. Doesn't clash with an existing community's usage of that namespace. Like, it's really nice to be able to say npm install foobar rather than have to put in a really long string with a kind of a domain name and lots of other things. That does bring its own problems with typo squatting and other elements alongside it. But in the short term, at the start of the kind of the seed of creating a new package manager, it can be a very enticing thing, as well as not really requiring any permission from anyone else. If you're pointing your new package manager at a new domain, then your registry is kind of like all you need to do is buy a new domain and set up a registry to be able to have a brand new namespace and start with that. And also a big driver for, at least to begin with, the kind of like starting hacking on new package managers is that kind of personal satisfaction. It's a fun challenge, and potentially for a new language or a new community, the package manager can kind of be one of the first big complicated applications. It has a registry side often and a client side to it. So there's a lot of challenge for the kind of person that gets involved in a new language. Often is like, oh, this is great. Like I really want to get my teeth into something like this. Also builds a lot of respect with this new community. If you are one of the early adopters and you have built the package manager for everyone else to use, and it gives you a certain element of control over the community. If you hold the keys to this new package manager, you can make a lot of decisions on how to direct the development and how the community should act as well. Like if you choose your registry needs a lot of kind of permissions to be able to publish new packages, then that can shape the way that community behaves in quite a strong sense. And for a lot of people, the kind of the idea of starting a new package manager is fun. The fun may drop off quickly once you run into all of the kind of longer term problems of trying to maintain a package manager for a whole community and the registry that comes along with it. But that can be one of the reasons why divergence happens. The other thing that I thought a lot about with these questions was when we talk about shared components and libraries. When looking at language package managers, often like the drive is to want to have the package manager written in the same language as the programming language, because it enables those contributors to the users to also be contributors to be able to understand the code. The problem a lot of language package managers run into is any time that it needs to bind to another language. C is usually the kind of the worst case, but the most popular is that you'll have an FFI out to some C library. Most of these language package managers, the actual kind of code or integration into other languages is a bolt-on at the end, or like a last thought, and not particularly kind of planned up front. And So if you were to say, well, more of our packaging is going to be written in a shared language, whatever that language would be, do you end up needing infrastructure to deliver those shared components, as well as some way of ensuring if you're doing cross-language or cross-platform installation, you're going to need to build and make sure that those things run in all different cases. Essentially, what you end up needing to do is have a package manager for installing the package manager that uses these shared components. And then what's that gonna be? And did you just recreate the problem over again? But on a slightly more positive note, I think there are a lot of pieces of the less technical aspects and the more kind of fluffy human sides of things that can be shared between package managers, even if it's just the kind of education and learning about what to do when you reach certain scales or you reach certain security problems as you scale up a package manager. Can you shake out certain patterns in good design practices that people can then learn from and work into their designs as they make new package managers, rather than making the same mistakes that other people have? Probably. And I think a lot of the infrastructure in terms of actually running large registries and moderating and ensuring the governance of all of the people involved is going to be like one of the most similar things in setting up these package managers and maintaining them as they go forwards. That although you probably don't want to have one gigantic organization that's running them all, you can definitely take their kind of patterns that they found that work, and at least the problems that they know how to deal with when someone reports a security problem. Like, you don't want to be my new package manager suddenly, oh god, what am I going to do to like, what's the best practice in following this security vulnerability or a security problem in my registry itself, in actually like getting that out to the end users of the package manager in a reliable way that doesn't cause everything to kind of fall apart. As well as the funding is also another interesting area, because a lot of these package manager registries, once they reach a certain size, all have a similar kind of set of funding problems. They're not hugely expensive to run, but they are seen as kind of this invisible infrastructure that often isn't a really sexy thing to try and fund from a funder's point of view, and so it can be a little bit tricky. But if you have that shared kind of understanding of grant making and other ways of funding those things, then teaching different package manager maintainers and could be a really good way of ensuring those things are financially sustainable. I think that's it for me.
All right, thanks, Andrew. I think we'll keep it for questions after everyone's had a chance to go. But if people want to ask questions in the chat, please do as we go along. All right, so let's go to Joshua.
Hey,
And the update framework has been mentioned a few times, and Joshua is one of the developers of that. So let's hear what he has to say.
Thanks. Yeah, so I'm going to be probably a bit more of a fence sitter because I'm not directly involved in package managers, and I think we've, even through the course of the conference so far, we've kind of recognized that we can't even necessarily agree what a package manager is. It's clear that there's a vast difference between kind of NPM, RPM, and say Guix, but they serve different purposes and have different goals. I don't think we're able to say we should have fewer of them, but I do think the differences are interesting to better understand. For the question of what can we automate or replace by infrastructure, my experience, having worked around package managers for a long time, was a big contributor to Open Embedded and the Octo project, and have worked on packaging software and helping people to package software. And it's my experience that a lot of developers have little to no interest in doing that kind of work. So I think one thing that would be great to automate and replace by infrastructure as much as possible is the actual effort of packaging software. And believe me, I understand, having worked on a cross-compiling system, that it's not easy to do. But there are common patterns, especially in more rigorously defined, perhaps, build systems. And we see a lot of kind of effort in individual projects. Like the Octo project did do a bunch of work on this. I think Guix has some fairly nice importing tools, including like a JSON format for defining the basic information about a package to try and import. And I think this is a really a good place to do more automation and indeed more sharing, which is the next question. What can we share? The other thing I really think we can do a better job of sharing is like the infrastructure. And Andrew mentioned this a bit, like the actual content repositories. There's kind of, to my mind, there's from source package managers like Guix and Gentoo's package manager, which clearly some kind of artifact store doesn't make sense. But for the rest of package managers, where there's some kind of like binary format, do they all need their own backend to manage storing software and having some kind of index that they can query? Can we share more there, especially as increasingly these places have got targets on them, as we see a massive uptick in supply chain security attacks. So I'm interested. I saw that Homebrew recently switched to using a container registry as its kind of repository backend, and I'd really like to learn more about that. And I haven't been able to find any of the technical details on that yet, but I'll be scouring the schedule here to see if any of the Homebrew talks are going to provide more information about that. And I'm hopeful that as we think about this, if we had fewer types of repositories, backends, it'd be easier to threat model and secure the communication between a client and a repository. So another question was, how can we make this happen? How can we have more packaging communities come together? And I really think this conference has done a great job, because package managers like Linux distributions and text editors tend to elicit very strong emotional responses. And so having more folks in these communities, which tend to be, in my experience, fairly isolated, insulated, actually come and share and collaborate is a really great start. I'm also personally very interested in how we make the binding between source and a package more transparent. We've got talks at the conference about reproducible builds and the Salsa projects, and I think doing more work in this area and sharing more ideas in this area, moving away from doing builds on developer machines towards kind of stateless and functional packaging, I think is a really positive direction for having greater visibility into what a package is actually introducing onto a system that you install it into. And I think more of the kind of the nitty-gritty details of package managers without having to read a package manager's code would be great to share. So final question was, how do we help those outside the package manager community understand? And I think one of the themes of the conference has been like taxonomy. So if we can somehow get a package management anthropologist to help us clearly define a taxonomy and be able to more clearly communicate, that will also help us spot patterns and areas to collaborate, I hope. So yeah, that's my run through of answers.
All right. Thanks, Jonathan. And last we have Ludovic. Do you have slides, Ludovic?
I don't have slides, so if you can just display the questions, that'll be fine.
Okay, I'll share and put the questions up. Let's see.
Right. So yeah, the first question was, do we have too many package managers? And that's funny, because that was already a question some 20 years ago when I got started into GNU Linux. There were already many Linux distributions and many different tools doing more or less the same thing. And, that was already kind of a running joke. Do we have too many package managers? But today we have even more package managers, because basically every programming language comes with its own package manager. And I used to think that, this is just a waste. We should have just the one true universal package manager. But it doesn't work that way, actually. It's also a social problem. In the sense that if you're building a language, you're also building a community, and you want to make sure you're helping people who use your language to actually come together and share their work, share the software. So in a way, it's kind of ironic because I'm working on a universal package manager, but I think that I understand that we need a very specific package manager. So it could be for a language community, or it could be for a specific topic like bioinfo or HPC, for example. That makes sense. I mean, I can perfectly understand why we get there. All right, I don't see the questions, Todd. I don't know if you have the slides at hand. What's the next one? Yeah, so in terms of what can we share? So I don't think package managers can share much in terms of code, or maybe on very specific bits like dependency solvers for some package managers when it applies. Or if you look at similar tools or tools in the same area like Nix and Guix, for example, they follow the same functional model. So they could probably share some pieces here and there, but maybe even not that much, actually. What I think we can share is more infrastructure, as has been said before. So in terms of import, like if you look at Guix, we spend a lot of time importing packages from other repositories like PyPy, CPAN, all those repos. And so if we have good, accurate packaging information, we can more easily make those packages from PyPy, for example, available via Guix. And then we have, people can choose to install packages via pip, for example, pip install, or they can choose to run Guix install, and that provides them a different set of functionalities, or better integration if they use Guix for other packages, non-Python packages too, for example. They can have a better integrated system. So if these language-specific repositories can share accurate information, and that's more and more the case, then that's something we can definitely share among package managers, because we can all have our own package manager which addresses specific needs and yet benefit from packages from those repositories. So in what other ways could packaging communities come together? So my experience with one community in particular, with the reproducible builds community, is that we can share a lot on methodologies, more than on actual pieces of code, for example. So if you look at the reproducible builds community, a lot of distributions and package managers and build tools came together to discuss, how to achieve deterministic builds. And there's really a lot to be shared, both in terms of learning how to improve our methodologies, or also in terms of providing new tools like DefaultScope, for example. That's a tool that allows you to compare two binaries if you want to find out why your builds are not deterministic. And there's definitely a lot to be shared in that area. And the same goes with the bootstrappable.org community. There are people from different backgrounds, different communities coming together to try to address bootstrapping issues, and that works pretty well, I think TUF, also the update framework, has taken a very fruitful direction by providing a specification that can be implemented by different package managers. That's a bit closer to actual code, but still, that's a specification, so people can just take it. They can implement it in their favorite language if they see fit. So that's one way we can share efforts. What do we need to do to get people outside the packaging community to better understand these challenges? Well, that's a tough question. I guess each one of us in each project is focusing on very specific aspects. In Guix, for example, we insist a lot on reproducibility, be it deterministic builds or reproducibility in a broader sense, like how can I reproduce my software environment at different points in time or on different machines. So that's something we insist a lot on, and I guess every package manager has a special focus that they insist a lot on and discuss in talks and conferences. So I think that works quite well, right? Everyone is pushing forward a specific part, a specific issue, and I think that's working well so far. Yeah, that's all I have to say.
Okay. All right, thanks. And we have some questions from the audience now. Let's see. So the first one, let's see. How much commonality is there between language package managers like pip, CRAN, and system package managers like Spack and APT? Does anyone want to take that? I mean, Ludovic, you kind of mentioned that in your talk about basically just, how you used to think about Guix and how you think now. Do you want to kick that question off?
Yeah. Right. So I think if you look at tools like apt or Guix or all these universal tools, I think apt and Guix and more are trying to be universal package managers. So we're trying to provide a tool that allows you to install packages in any language, and that's really the core tenet of these tools. Whereas pip and cran and so on initially started as tools that would allow you to install just packages in that specific language. And so, that's how it starts. But my impression is that eventually you have to go further, right? Initially you say, okay, I'm going to write a package manager specifically for Python. But it turns out that, the language is not, the world is not monolingual, right? So at some point you have Python packages that call out to C code, for example, and you need to find a way to deploy that software, right? And so if you look at pip, for example, it has ways to deploy non-Python software next to Python software because it needs to do so at some point, right? There's user demand. So I think in the end, every package manager tends to be more or less universal in some way.
Yeah, I also just saw CMake being packaged on pip, so it's happening.
Yeah.
Yeah, people are using pip to install everything now. It's a little disconcerting because pip has probably the least validation of binaries of any of the package managers out there. But yeah, I guess, what about solvers? I mean, so the question was about common infrastructure, and there seems to be a divide between package managers that have sort of an ad hoc solver, ones that are doing sort of a full-on dependency solve of some sort, and the distro managers. You want to take that, Andrew? Was that the way?
Yeah, there's one kind of element of how they maybe a slightly different way of kind of slicing the taxonomy of package managers is thinking about how that metadata is stored as like a collection or a registry, where you see kind of, I guess, more traditional package managers will have you essentially sync the full list of all packages down before you go to install, and you kind of have a whole bundle of everything, and it's all kind of right there. And maybe that's multiple different registries, as you say, like app. You add in another apt repository into your configuration. A more modern or contemporary version of that would be the crates Rust package manager, which Git clones this gigantic Git repo full of JSON files and fast forwards it. Homebrew does a similar thing. And that kind of means that you have all of the information right there. When you go to do your dependency resolution, it's all local. Whereas a lot of language package managers have kind of the database, the registry is on a server somewhere, and you kind of make ad hoc queries to say, oh, well, I want to install this package, and it says it's got a dependency on package foobar, I better go get the metadata for package foobar, and then foobar has some more dependencies, so I'll go fetch that as well. And you're kind of lazily fetching all of the dependency information as you go. A lot of that kind of works really well in the small, when there are less, especially as language package managers, at least to begin with, have less packages in them until the thing has grown to a certain size. It kind of works. But if you watch the HTTP logs that an npm project would install, it could easily make 1,000 HTTP requests from an empty cache. That trying to get those two kind of different approaches to how you would load dependency data to do those resolutions together is very, I can't imagine those two things connecting very well, because the fundamental design of those registries says, like, either you're going to make it easy to be able to collect and share that, like the end user can fetch all of that metadata in one go, versus the end user is going to fetch those things kind of independently and be entirely dependent on the registry as well. And I think those two different approaches are very difficult to try and connect the dots between. But the registry kind of approach of, I'll sync all this data to the client, makes for, like, they have the very same pattern between all of these different registries. Obviously, the format of that data is different, but it's not like out of it. It could be changed in theory to say, or at least it could be converted to be able to reach a similar kind of format and be able to reach some level of shared understanding between different registries. Trying to actually get them to be able to do cross-registry, cross-package management communication, I think would be a really interesting way. So say, like, rather than pip is going to install C stuff, can pip be able to say, I depend on something from another package manager?
So I have opinions about that.
Yeah.
I guess, well, I guess I'll jump in here. I think this whole discussion is related to one of the questions. So I'm going to skip one question and put this one up. Which is, like, how do we get a common language for package managers and build systems to communicate? I guess, like, we have thought about this for Spack, and if you saw the talk, I mean, we're trying to make a really general dependency resolution mechanism. I think the challenge that comes up is that the actual packaging model for different systems is not necessarily compatible, and some is like a superset of others, some is a subset of others. And so, like, if you wanted to import a description of the, say the C linking model, or maybe even NPM's package model into pip, it doesn't fit. And basically you need sort of something underneath that the superset of those things, and then you could actually fetch data from an API. I mean, one thing we would like to do is what you described is just query PyPy for Python information. But even in that scenario, it's hard because the PyPI contributors tend to overspecify their dependencies, and so, like, you get constraints that are sort of too narrow for a system where you're trying to mix more things than PyPy had in mind. And so, like, I think, yeah, go ahead, Wolf.
Yeah, I also think that, like, using PyPy would probably be, like, the wrong source, because, like, one strength of having a packaging community is that it's concerned about packaging, and PyPy is more like a community where, like, the author of the software puts their package, but not necessarily.
That's a really good point. And another good differentiator between language package managers, or at least contemporary language package managers, and system, or more kind of the universal package managers, is who's packaging and who's in control of those packages. One of the reasons that a lot of these language package managers appear is because people want to ship their packaging libraries up that are used by multiple different languages, and they want to be able to quickly roll those versions forwards. So they're almost always having the author pushing out a version, and maybe someone has forked it and has their own version under their own namespace or they've just like added dash foobar on the end. Whereas, you wouldn't really be able to say take Ruby gems and try and test every combination of every different Ruby gem at the same time and go like, okay, well, we've got a version of a snapshot of Ruby gems that works. We have tested. Whereas you could take a snapshot of a Ubuntu apt registry and be like, we're fairly confident that this particular snapshot works for this set of constraints for these users.
Mm-hmm.
Yeah,
so do we need a consequence? Go ahead.
Good. I was just going to speculate whether it's a consequence of targeting a system and trying to be a good citizen on that system that there's more explicit kind of curation of the content that goes into a system package manager and more explicit processes to observe. Like that certainly seems to benefit from a security standpoint, right? By having to conform to certain expectations, you tend to get more eyes or processes involved and more linting and things, whereas the language package managers tend to be developer packaged often, or whoever just can open submit to the repository, and the system package managers, for some reason that isn't always clear, tend to have a more rigorous process, which introduces more opportunity to catch these malicious contents.
Would the language package managers, at least maybe naively, are for like pieces of code as opposed to kind of programs that have been wholly kind of packaged up and are ready for, you've got like developer users and then end users that are kind of like a system user that wouldn't be expected to like download a Ruby gem that is a Rails plugin that's part of another application almost. It's like the language package managers are before, or at least the from source ones are from before the pieces you're kind of arranging, and then the developer is going to decide what is the, like, I need to get a version set of these packages that actually my application will run, and then I will package that application up and deliver that to the end users, or I'll compile it into a binary that I know what, or at least pass my tests, that ends up in a system package manager, often either as a command line or as a some kind of desktop application. Is maybe a helpful distinction, but often gets muddled in like, oh, well, we want to install this Ruby package on Ubuntu. Well, we're going to have to package each individual dependency up as a Ruby package also, so that we can bump various fixes without needing to reach the original developer of that application.
Yeah, and the user-developer distinction gets really blurred with things like TensorFlow is a package on pip, because that's the easiest way. Like, most systems have a Python which comes with pip, so the easiest way to get TensorFlow on every system is just to tell them to pip install something. But there's like, I don't know, tens of lines of Python code in TensorFlow. Certainly a lot more compiled code in there than anything else. So the user versus developer distinction, I wouldn't say most folks using TensorFlow are necessarily developers. So the lines get very blurry.
Yeah, I think the big distinction between package managers is curation, like you mentioned, Joshua. If you look at the old traditional package managers like Debian on the old distros, they really insist on curation. Like they pay attention to what packages go in, and so they have the whole process to do that. Whereas the language package managers today are really wide open, which is great in terms of allowing people to quickly grow a community, and that works perfectly well for that. But as we know, it comes with drawbacks in terms of supply chain security in particular. So I think we have to find a trade-off. And if we consider like importing PyPy packages into more traditional curated distributions, it has to be kind of slow, because that's sort of a promise that Debian, Guix, etc. make to their user, that they provide a curated distribution, right? So they have to do that work at some point. Well,
but so this work is kind of duplicated across communities, right? Like Debian, Fedora, conda-forge, many others that provide like a set of distribution are doing this work and are doing the testing that specific versions work well with each other. And
so I'm gonna segue on this, and I'm gonna basically put up this question, which is, where can the community get funding to pay for shared infrastructure? And I guess I'll expand it to what Wolf is talking about now, and basically say, I think, what do you think about shared infrastructure? So I think that's where Wolf was going, is how can we actually, I mean, so conda-forge is leveraging basically all of the free CI services, right? And I think Guix has its own build farm. We have, we get some support from AWS, and we also provide our own cloud cycles and our own, HPC cycles for testing. And that CI can quickly get massive. What is the hope for some kind of shared packaging CI? Because I actually think consolidating it would make a lot of sense, because I think there is some redundancy in testing these different things in different environments. So you want to continue your thought on that, Wolf?
But for me, like what I would like to share is more like the knowledge, right? Like the kind of, and then maybe if we have some sort of like automated testing in one of our like distributions, basically, where we can prove that, okay, this version of whatever package works well with this other version, then we can make a link and say that's okay. Or like other ways of kind of having a central repository where we put the metadata of, for example, dependency constraints, and where we can also modify those dependency constraints in one central repository, and then it can propagate to all different distributions, and they can like accept that change or deny it, or like this kind of like wisdom that's encoded into all of our communities. I think a really nice outcome would be if we find a way to kind of merge that and centralize it somehow.
So other folks were nodding about the shared infrastructure idea. Did Ludovic or Joshua or Andrew, do you have thoughts on that?
Talking about that kind of shared knowledge, another, I don't want to segue off too much, but another interesting area of duplication that I think we have a good chance at kind of reducing is a large amount of the kind of security review and license review that happens on individual packages often never really gets publicly published. Like if someone does a security review of a particular version of a thing and they don't find any security problems, do you know if, does anyone ever publish that if they didn't find anything? Like this package looks okay to me. Is something that obviously there's a lot of businesses that have this set up, the enterprise companies that don't really want all of this information to be publicly shared, because it kind of affects their bottom line, because they'd like to resell that over and over. But as a community, if someone reviews the security or the licensing state of a package and finds that it's okay, that maybe having a place to share that kind of knowledge would also help to reduce some of the burden, to go like, okay, well, we can cover more things by everyone reviewing different packages rather than reviewing the same package over and over again, but never telling anyone their findings.
Do you trust other people's findings? I guess in that regard.
I mean, I npm install things on a regular basis, so my level of trust is pretty low.
Yeah. I mean, because even from a service that tells you that there's nothing wrong with it right now, like something could come in later, right? So like it almost is, it's like a positive is never final. So I'm curious how you would actually export that data without it being something like a service.
You would need some element of trust and social kind of reputation. It goes down quite a complicated path as you get further into that, I guess. But then we have that problem with packaging all over. It's just kind of unspoken about, like, if I give access to someone else to publish a new version of my package, in some package managers, you would never know who even was the publisher of that thing. There's no real signing in a lot of registries to say, like, did the original author even publish this, or did they lose their token and it got taken over maliciously without inspecting the source code to go like, oh, we spotted the maliciousness. Like a lot of registries, the signing kind of comes in as an afterthought rather than, especially in language package managers that are less, they're more focused on this kind of like, oh, we just have some tables of source code that we're flinging around. We're not too worried. There may be something like a lot of package managers don't really even use kind of fingerprinting or like a SHA-256 of the package recorded in their log file to be able to know like, oh, I actually got the same, this package looks like I got the same package. And this is a lot of, I think, the problem of kind of the understanding of when you come to develop a package manager, you don't necessarily, you're not aware of all of these best practices until they come back to bite you and you're like, oh, now this, I wish I'd known about this earlier. But trying to find this, I mean, this is the first packaging conference, right? Trying to find everyone and be able to talk to them about their experiences in building package managers. This is just happening now. And sharing that knowledge in ways that people can pick that up in an async way is just going to have a big impact on its own in enabling people to make the right decisions to make their communities more secure and stable going